Find the derivative of x cubed plus y cubed equals 8, a by implicit differentiation, b by solving for y explicitly and differentiating the result. Show that the results are the same. For part A, we're going to take the derivative of this implicit equation. Implicit means it's not solved for y in terms of x, but y and x are related to each other through the equation. We can find the derivative of this using implicit differentiation, which means just take the derivative of both sides with respect to x, indicated by a prime on both sides. The left side is an addition of functions. We have x cubed plus y cubed. We can take the derivative of each of those functions separately. The first function will be a power rule, 3x squared, and we'll add to it the derivative of the second, which is also a power rule. Bring down the power, subtract 1 from it, but then because we just took the derivative of a y term, we have a y prime to complete the chain rule. On the right side, we have the derivative of a constant. That's a 0. We want to solve for y prime here, and that will be done by isolating the y prime terms. There's only one term that has y prime in it. We will isolate that by taking all other terms, that will be this, to the other side. So our next step is to subtract the 3x squared term to the other side. And now y prime can be found by dividing by 3y squared. The 3's can cancel, and y prime is negative x squared over y squared. For part B, we want to solve for y explicitly and differentiate that result. This isn't always possible, and that's why implicit differentiation is needed. But if it is possible, this is an optional way to find the derivative. We want to solve for y here, so we'll start by subtracting x cubed to the other side. And now we will take the cubed root of both sides. So that we have now y solved explicitly in terms of x. And we can take the derivative from here. But before we do that, we will want to rewrite this radical as a fractional exponent. It is a power of 1 and third root, so 1/3 power. The derivative of y prime will then be a power rule. We will bring the power down, 1/3. Leave the inside alone. Subtract 1 from the power. I will call that 3/3. And then multiply by the derivative of the inside to complete the chain rule. We can multiply this constant and this constant. Everything's multiplied here. That will give us a negative 3/3. We can also move this x squared out to the front. And then we have the 8 minus x cubed to the 1 minus 3 negative 2/3 power. 3's can cancel. And so we have a negative of the numerator is x squared, and then the 8 minus x cubed to the negative 2/3 can move to the denominator and become a positive 2/3 power. And there's our explicit derivative, y prime. We want to show that these results are the same. Right now, they have the same numerator. We have a negative, we have an x squared, but the denominators look a little different. However, we can rewrite the denominator for the one we just found as 8 minus x cubed to the 1/3 power, and then the entire thing squared. Because 1/3 times 2 is 2/3. The reason we do that is raised to the 1/3 power is y. And we can replace that now with a y, and we have negative of x squared over y squared. And therefore, the derivative is also negative x squared over y squared, which is exactly the result we have in part A. So these derivatives are exactly the same.